Assalamualaikum. Hi guys, welcome back to my channel. So, today's video I want to talk about one of my course in university, which is Calculus 1. In Calculus 1, we will learn about limit, differentiation and integration. So, for today, let's look for differentiation. So, what is differentiation? Let's look some research in Google.
In Google says that differentiation is a process of finding a function that output the rate of change of one variable with respect to another variable. So for more explanation, let's enjoy this video.
The first branch is differential calculus, and this involves the concept of the derivative of a function. This branch of calculus studies the behaviour and rate at which a quantity like distance, for example, changes over time. When we use the process of differentiation, we are essentially analysing the changing rate of a quantity and making predictions about its behaviour. So by finding the derivative, we can find the exact instantaneous rate of change at any point we like. If a function has a constant rate of change, we get a straight line, and it's easy enough to just find the rate of change using rise over run. However, when a function changes its rate a multitude of times, by using differentiation we can find exactly what its instantaneous rate of change is at any and every point in time.
You must have wondering why we must learn differentiation, right? Like when we do apply differentiation, or what are other application of differentiation. So if you want to know more, I have one friend which is more expert in this topic. So come, let's know her.
Hi, my name is Saffrina. When we apply differentiation, when you realize differentiation helps us through many things. We are able to find the rate of change of one quantity that respect to another. Some of the examples are to calculate the profit and loss in business using graph, to determine the speed or distance, to check the temperature variation, and others more.
By solving the application of differentiation problems, the concept of application will be more understood in better manner. So, let's do a question.
This is an example of related rates question. A cylindrical water tank filled with water has a radius of r cm at the top and h cm high as shown in figure below. A. If the height of water is twice the radius shown, that V equals to 2 per 3 pi r cubed. B. Water flows out of the tank at a rate of 50 cm per second. How fast is the radius of the surface of the water changing at an instant when the height of the water is 4 cm? So, the objective of the problem is to show that whether the volume of cone is V equals to 2 per 3 pi r cubed. And second, to find how fast is the radius of the surface of the water changing.
So, how can we solve this problem? Maybe Saffrina can help us.
So, in related rates problem, there are some steps to solve it, such as: first, draw a diagram if possible. 2. Label the quantities. 3. Find an equation that related rates of change is to be found to the quantities whose rate of the change are known. 4. Use the chain rule or implicit to differentiate both sides of the equation with respect to time. 5. Solve the derivative that will give the unknown rates of change. A conical water tank filled with water has a radius of r cm at the top and h cm height as shown in the figure below. If the height of the water is twice the radius, show that V equal to 2 over 3 pi r cubic. First, we have to write the formula of the cone. The information given that the length of the water is twice the radius. So, H equal to 2R. Then, substitute H into the formula. Then we will get B. Water flows out the tank at a rate of 15 cm cubic per second. How fast the radius of the surface of the water changing at an instant when the height of water is 4 cm. The information given that the water out at a rate of 15 cm per second. So, dV per dt is equal to negative 15. It has negative because the water is flow out. Then, the information asks how fast the radius of the surface of the water changing at an instant when the height of water is 4 cm. That means dr per dt, the question asks, and the height is 4 cm. To find R, we know that the height of the water is twice the radius. So, R equal to H per 2, we will get 2. Then, to choose dV per dr, we have to differentiate V, so we will get 2 pi R. So, dr per dt is equal to dt dr dV dV. Substitute this information into this equation. And then substitute R equal to 2 in this equation. Then we will get the answer is centimeter per second.
So that's all from us. We hope that this video helps you to more understand about differentiation and helps you to solve some problem of related rates involving geometry formula and function. So I will see you guys in my next video. Bye!